Alright, what's going on, everybody? Happy Halloween. This one is going to be a StyroPyro video, which I know his channel, I know his content is really good, and I'm excited to see what this is about. 100 car batteries can put out a lot of energy, so I'm very excited to see. Let's just get into it and see what it is.
This video is sponsored by AnyDesk.
Man, my sister has AnyDesk on her computer. It is terrible to get off. Because she doesn't have a license for it. It's impossible to get off of the computer. It sucks. But I'm sure it's very useful.
You ever wake up in the morning and ask yourself, what happens when you wire 100 car batteries in parallel? If
I
so,
do that. Yes,
you're in luck
all the
because
time.
that's exactly what I'll be doing today.
By wiring all these in parallel, the voltage is going to be the same as a single battery, which is just a bit over 12 volts.
Now I realize this seems lame compared to what I usually show on this channel. But you see, this isn't a video about high voltage. Oh no, we're playing with fire today.
See that rating right there? That's how much current this battery can deliver for 30 seconds in freezing temps, and that's 850 amps. So, by wiring 100 of these in parallel, we're looking at 85,000 amps. Of course,
That's a lot of
cable and
amps.
contact resistance is going to limit that somewhat, but I'm curious to see just how ridiculously high the current can get here. I mean, it's one thing to produce thousands of amps for a tiny fraction of a second. But what does it look like when you make even more than that over a few seconds? In fact, I'm hoping to achieve the currents seen in a lightning strike with these batteries.
Continuous?
The most daunting
or?
engineering task for this project was coming up with a way to switch these massive currents, particularly one that can break the circuit when tens of thousands of amps are flowing through it. I settled on modifying a log splitter, mostly because it can rip apart contacts that weld themselves together.
Now the best part about this switch is that you load it like a crossbow. So let me show you this beautiful mechanism here. So I gotta yank this back while feeding it this pin. It's not very easy. Let me just show you. Okay.
So is the glass there for like safety? Like if you notice there's glass between the two contactors. If the glass wasn't there, would this thing like dump current? No, it looks like on the left maybe. I don't know why the glass is there. You tell me in the comments if you understand.
Now it's loaded, and I have to feed this actuator. So
I'm a
it can yank out
dumbass who doesn't know anything about electronics, so.
that pin. Let me just show you. You can see the actuator there that yanks out that pin. So now, when I hit this yeet switch, those contacts slam together. And then if I have some catastrophic failure and need to kill power, I just press this frick button here to rip apart those plates. Oh, and I also have to yank the string at the same time. Seems
Not
safe
ideal.
enough, right? Now, I don't want to bore you with numbers, but I feel like it's important to give you a sense of the quick,
Is there a reason to also have the string? I feel like you could just tie, I don't
easy
know.
scale that I'm
don't
dealing
know.
with here. That bank holds an incredible 320 megajoules of energy. That means that if one of those batteries fails short, the energy equivalent of 500 cars screaming down the highway would get dumped into it all at once, which would probably make a sizable crater. I really
Yeah.
hope that doesn't happen.
Hopefully.
Now I could go on and on about how clinically insane this is, but I should let the rest of the video do the
Feels
talking
wrong.
here. I will say that you definitely shouldn't play with car batteries. I mean, even one can mess you up.
I mean, I'm a dumbass, so I don't know what would be wrong about this, but it doesn't feels wrong. This doesn't feel right. Shouldn't be laying on all those batteries.
If you abuse it enough. So yeah, don't try this at home.
For the first test, I'm going to try a piece of 1/4-inch threaded steel rod. This should be easy to melt, but the small size will probably limit the current somewhat. Here we go. It looks like the connection broke there. I mean, it is only 12 volts, so nearly anything can break the circuit here. I went ahead and smacked the threads with a hammer a bit to hopefully give more area of contact.
Ooh. Wow. I wonder how bright that is. If is he filming at the same time, or is this later in the day? Because you can hear like the nighttime in the background.
It was slower than I hoped, but I did like the green flames from the zinc plating burning off.
God, look at how bright it is.
Here I have a 3/8-inch threaded rod. Now this has over double the area of the last rod, so it should pass quite a bit more current. Here we go.
Like, is this pitch black nighttime or what?
Look at that. Wow.
It got hot.
Cool. I think that one was just as fast, if not faster.
So this is nighttime?
Let's try zapping some ferrocerium. Now this is the metal alloy that makes up modern lighter flints, and it makes a bunch of sparks when it's ground down. I'm hoping it makes even more sparks with these batteries. Here we go.
It's just gone.
Oh, it just exploded. Maybe a bigger rod will give even more sparks.
There we go.
Ha! I'll take that as a yes. Unfortunately, it didn't actually burn all the way through there. Gosh, it's just so hard to keep contact with the voltage being so low. You guys just need more weight. This is a kilogram ingot of bismuth
Why
metal.
not just up the voltage a little
It's
bit?
super dense and melty, so I'm hoping it will keep enough contact to melt all the way through.
It did not keep enough
Well,
contact.
that was messy. It splattered molten metal all over the place, although a lot of it was unmelted. It still made a nice puddle, though. Plus, the oxide layer on the remaining ingot is super colorful. I want to try zapping this half-inch bolt, but this time I'm going to measure the current through it by looking at the voltage drop across the cables. Here we go.
It does not want to stay in contact.
It took a while for it to secure contact, but once it did, it melted pretty quickly. The oscillogram is noisy, but once it made full contact, there was a drop of about 180 millivolts there.
I wonder how much, like, electromagnetic energy is put out from this. Like, how much interference you'd get if you were... Like, if you set up, like a... What the hell are they called? If you set up, like, an antenna, what it would look like?
Now this is across a mere 16 millionths of an ohm, which means the current there was about 11,000 amps. Not bad. Let's give this saw blade a try. It's nice and flat and conductive. It should pass a substantial amount of current. Fire in the hole!
Huh.
It certainly burned through quickly. I was hoping it would explode or something. Oh well. The current there was higher.
Oh well.
A peak of 15,000 amps. Now that's probably near the limit without making some modifications to the circuit. Now if I can do 15 kiloamps for a few seconds, now that would be pretty crazy. And it might be possible with this 3/4 inch bolt here. Here we go.
Wow, it's like blasting away.
For as easy as it is for wires to short when you don't want them to, it's been bafflingly difficult to hold a short across these batteries. Everything just keeps blowing out of place. I've tried using all sorts of clamps and different materials, but the results are all the same. Everything breaks contact.
There's so much
This
energy.
bank is scary. However, its voltage is not. And that's why I can do this and not feel anything. And besides, at only 15,000
Scary.
amps, I haven't even hit the current of the average lightning strike yet. Are you telling me some clouds can do better than 100 car batteries?
So, is it time to throw all these batteries in the ocean? Nope,
Yep.
not yet. I think using a higher voltage will overcome these problems. So I rewired the bank for a series
Nice
parallel
butterfly.
arrangement. Now there are chains of 5 batteries in series, then all of those are wired in parallel. This makes the fully charged bank sit at a little over 60 volts. Let's
Looks
start the
meaner
60
now,
volt
too,
experiments with
with the
another
copper.
3/8 inch steel rod. Here we go.
Oh yeah, that's more.
Holy heck, that exploded!
The slow-mo shows something astonishing here. The rod heated so quickly that its zinc coating boiled off faster than it could burn. And then when the rod finally exploded, it left a cloud of greenish plasma as the zinc vapor reacted with the oxygen in the air. Comparing this to what happened at 12 volts, it's clear there's substantially more current at 60 volts.
Yeah.
Sure enough,
very
I
clear.
clocked a peak of 30,000 amps, which so happens to be the current of the average
I wonder how the
lightning strike.
copper doesn't melt.
I still think I can do better, though. Let's see what happens when I try a half-inch bolt.
Ooh.
Heh, I guess
Sounds
those little
loud.
clamps weren't enough. I've upgraded to some big boy clamps this time, so hopefully this does the job.
Nope.
Damn it.
I'll take that as a no.
Yeah, that bolt really does not want to stay in those blocks. In fact, let's take a look here. Yeah, look at that. It just leaves like a big crater of splattering molten steel and copper. Wow. Let's see if quad clamping it will hold it in place.
I guess it's just too much force.
Heck.
Maybe you could like make a jig out of wood to hold it in place.
This was easier at 12 volts. What's going on here? Slow-mo shows the increased current has introduced a new problem. These blocks are getting ripped apart by the gayest force field in physics, the magnetic field. Now what's so gay about magnets? It turns out, opposites don't always attract like you might think. Yeah, when you consider magnetic dipoles, north attracts south and vice versa. However, if you look at currents that give rise to those fields, you'll see the reverse happens to them.
Wow.
Opposite currents repel, and like currents attract. Now this has a lot of interesting consequences in physics. It's why lightning pinches itself into a fine streamer, and it's also the basis of experimental Z-pinch fusion reactors. In this circuit, it causes the aligned cables to bunch up,
Experimental Z-pinch
or
fusion
repelling
reactor,
the cables carrying current in the opposite direction. And this is what's ripping apart the copper blocks. In an attempt to fix this issue, I brought in two of the leading experts in crackhead engineering, Alan Pan and the backyard scientist.
So,
it's Bear Trap
I've already
Man.
tried blowing this thing up before,
And
but
Alan
like,
Pan.
the current is so gigantic and the magnetic field is so huge that like it doesn't want to stay on the block.
Yeah.
Yeah.
I wanna see what this does.
Yeah. It's like you may not be safe, but like we'll do it. Yeah, we'll do it.
That's like an inch thick copper.
Oh yeah, it's literally an inch thick. We're gonna take this bad boy.
Oh, so that just, oh my god.
But the thing is, these huge clamps, they're not enough. It's not, it's the forces and currents are just so big.
Yeah, I want to put this last clamp on. Yeah, there we go. Oh, yeah. This is completely insane.
This is deranged.
This is like, this
so
is
bad.
just...
All right, everyone ready?
Yeah. Ready?
All right, here we go.
Oh!
Oh! See, it blew out of there again. It blew it out. Do you see that? How that was? Do you see the brown smoke?
Yeah.
Cowering behind a barrel.
Yeah.
Why does he even have a barrel there? Where do you get a barrel? Why do you just have one lying around?
That was like a firework from
Like
hell.
it all shot out sideways.
Yeah, but the contact broke in like a fraction of a second.
Wait, is it safe to look up close?
Sorta.
So the bolt is actually still there.
Yeah, so that's the problem here. Is the
It just moves it across like.
yeah, so there's two issues. So it explodes, and but also the magnetic field is all opposing and it yanks it apart. So like it barely held on. Like how would you fix this? Like how would you guys find a way to actually keep things on the block?
Probably just use some of those plumber's clamps onto some wood. Even just fucking... Because they're bolts, right? They're like square on. You could just... Make a little jig out of wood. You could probably cut something out of the wood, you know, to hold it in place or something. I don't know.
And blow up. How would you do it?
I think I could do it.
How would you do it?
I could do it.
Oh, you just could, yeah.
I just
Hold it, yeah.
Just hold it in place, of course, yeah.
Dude, I don't know. Could you
Oh,
just
man.
like drill some holes in the copper blocks and like through bolt it to a piece of wood or something like a 2x6,
Yeah.
and just force them in
Maybe.
position?
You might be able to.
I feel like you don't want to keep everything in position. I'm scared. Like if everything was locked down, I'm scared of what could happen.
Sure.
No, I want to see it
Well,
locked
like,
down. I want to see it
that
locked
bolt
down.
explode. I
Like
want to see
red
it
hot
explode.
and,
Yes.
yeah.
And melt. Yeah.
Because he's got that big ass contactor in case anything goes wrong.
Kind
So
of
it's
bolted
probably
them to a
fine.
piece of wood, like on the same piece of wood, right?
That's what I was saying.
Yeah, okay, that's what you were saying.
Oh, so
Yeah.
you have the whole
Yeah, it's
mechanism
like, it's
bolted
like
together.
one piece of wood.
Oh, that's a good idea.
Yeah.
Like I was just expecting like melting and explosive stuff, but not a magnetic force. That's insane.
Also, those expensive cameras are really close to this.
I do like the block of wood idea.
The German word for horror and
It is a good
respect.
idea.
Oh, yeah.
whatever that word is.
Yeah.
Before attempting to bolt everything down to a block of wood, we decided to stick a couple cans of 1,2-dimethylethane on the apparatus.
As you do.
All right. You ready for this?
I'm ready. I don't usually.
That
wear
table
safety
will
goggles.
not stop anything, man. It's made
Ready?
of plastic.
All right, here we go.
Oh my gosh. Whoa. Wow.
Whoa.
Oh, it's still alive.
I'm gonna clear it off, alright?
Oh, it's gonna spark. Be careful.
Okay.
I would never, bro. I would never.
That was all the can.
Wow.
We tried sticking a can upright with the hope that it would act like a rocket. It turns out this worked just a little too well.
Straight towards them, man.
Whoa! It ended right there. Yeah. Oh. Wow.
Whoa, it came right at us.
Wow. These fireballs were cool and all, but they also had the function of clearing out some of that annoying grass out in front of the batteries.
Terrible, annoying grass.
I went ahead and mounted everything to a big block of wood. Now let's try another half-inch bolt. Here we go. Yes! Wow. It just exploded off of there. Wow.
I wonder what titanium would look like, because I don't know if you guys know this, but when titanium gets hot, it like explodes because it reacts with the air. So I wonder what titanium would look
That's
like.
terrifying.
Titanium's so
look at the
expensive,
remnants
though.
of that bolt there. You're welded on there. Wow, it looks like it took about 1/4 of a second for that to melt through. And yeah, it peaked at over 40,000 amps. That is insane. The slow-mo shows two powerful magnetic effects here. There are the cables in back violently pinching themselves into a bundle, and also, there's the broken bolt fragment getting launched outward due to the magnetic forces on it. Well, if the half-inch bolt melts now, maybe the 3/4 inch bolt will melt too.
Oh. What happened?
It melted through. Wow, that is really melted on there. Interesting how it like hollowed out the nut there.
I wonder why I did that. Is that ever coming off?
I don't know if that one's coming off. My goodness. Yeah, that liquid steel really
Might need to chisel it.
bonds into the copper there. Okay, there it goes.
That'll work.
Jeez. It's funny, because as I keep trying bigger loads, sparks get launched further and further, even beyond where I'm hiding for these shots. I figured these tests would be intense, but they're already beyond my expectations. This one's gonna be pretty crazy, I think. There's that bismuth ingot that I couldn't melt earlier. Here we go.
Ooh, yellow.
Huh. I thought its own weight would be enough to hold it down, but clearly not. So I've used
Those
these
clamps are not
to
going to
hold
do
it down
anything,
now.
man. Oh, apparently they did. Wow. I wonder why it's yellow smoke. Also, did you hear that? Liquid, it sounded like liquid landing on the ground near the camera.
It made a huge mushroom cloud. There's not much of this thing left. It just splattered and vaporized all over the place. Wow. I also managed to spray molten metal on the lenses of 2 of my cameras with that run.
Yeah,
Oops.
so expensive,
At
man.
this point in the video, pretty much all the footage is terrifying. But even so, this is probably the scariest shot so far. The batteries managed to take
You can
nearly
see
an
the
entire
liquid
kilogram
coming
of
straight
metal
to the
and turn it
camera.
into a cloud of vapor and liquid in a second. The droplets being shot out are so
at it.
hot that they're burning in air,
They hit the
leaving little
camera.
trails of smoke while raining burning molten metal on everything around it. Afterwards, I found bits of metal splattered on the trees, the sides of my shop, and even the table I was hiding behind. The impressive pyrotechnic display of the bismuth convinced me to try a stick of titanium as well.
Yes, let's go! This is gonna look sick, I'm sure. What?
Titanium is used in fireworks for making bright white sparks. And it turns out, it makes these beautiful sparks when being zapped
Yeah,
by
that looks
100
pretty
car
cool.
batteries as
That
well.
looks pretty cool.
Who would have guessed?
I want to
In
see it
engineering,
thicker, though.
There's something called a crowbar circuit, and it's used to prevent an overvoltage from killing the rest of the device. Now, it got its name because it shorts the power supply, much like if you were to take a crowbar and throw it across the power rails. Now, I think it'd be fun to try the literal interpretation of this circuit. I decided to start with a smaller crowbar here first.
right, for keeping his video intact, I think I'm going to cut out a few of these. And you'll have to watch the video if you want to see them yourself. All right, I'll cut back to here. So what just happened was all the fuses exploded. You got to go watch it yourself, man, but we'll continue on.
I upgraded the fuses to 4-gauge, but at this point the batteries are really being abused. So I'm going to do some other experiments before trying the big bolt again.
You're probably wondering how well this battery bank works as a plasma cutter. Well, I am too, honestly. There's only one way to find out.
That seems like so much fun, man.
Wow. That works even better than I expected. Well, the ground connection melted there, so now I just have it sitting on that copper block. Let's give that another go. I think that'll do it. Let's try that with some steel that's a bit thicker.
You can tell he did a lot of off-camera cutting because of how much shorter the thing is.
Oh, jeez.
Oh, losing it.
Come on. All right, let's try that again. I just want to cut it in half.
Wow.
It's close enough. Well, actually, on second thought, let's cut it in half the other way.
Wow. That looks so sick.
Wow. Wow. That
I'm sure this will look
wild.
awesome in slow motion.
Yeah, a few sparks in my head there. Wow, that was fun.
It's on fire.
I've
On
sprinkled
fire
some
there.
magnetite there inside that loop of wire. That way you can visualize the magnetic field.
Maybe that's why he decided. I was wondering why he decided to, like, why there was a cut when he said, let's cut it in half. On second thought, let's cut it half the other way. I'm sure maybe he thought to do this, and then he was like, I'll cut it a half the other way. And that's why.
Yeah, it really sticks to those cables.
I've placed the wire loop below a plastic tray for this shot. It's crazy how quickly the magnetite orients itself near the wire. But then again, the magnetic field here is probably a solid fraction of a Tesla. By attaching some LEDs to a coil of wire and placing it near the cables, I can get some rudimentary transformer action. Those LEDs are being wirelessly powered by the alternating magnetic field.
That can be a
I have this
tremendously.
big old SCR
That can be a tremendously efficient transformer.
here, which
I
is a
would
type
imagine.
of solid-state switch. I want to try popping it with the batteries. Here we go. As expected, nothing happens yet because the SCR is off and it holds back the battery voltage. Now let's do a little trolling and apply a signal to the gate.
Oh.
It's funny because I'm used to silicon dying when looking at it wrong since I'm terrible at electronics. However, the SCR was unaffected by this. The explosion was actually just the cables popping out of the contacts because they're only jammed in there. Let's give that another try.
The fuse blew again, it looks like, yeah. Or something like that.
Wait, are you serious? Did it? I don't think that... What? I think it melted the bolt first.
Much to my amazement, the magnetic field shredded the whole setup before there was enough time for the SCR to pop, conducting an astonishing 45,000 amps and snapping
Wow.
one of the mounting bolts in the process. That is one tough
Basically
piece
a
of
fuse.
silicon. I mounted everything back in the wooden block to keep it in
This is
place.
a silicon she
Let's
tells
try
you
that
not to
again.
worry about. Ah. Never mind. Rest in peace,
It
silicon.
turns out, the SCR had already failed short from the previous run, which is why it immediately blew up when the battery voltage was applied. This breaker says it can stop a 10 kiloamp fault. We'll see about that.
Alright, let's see how well this circuit breaker holds up.
If it says it can, it probably can. That's usually how these things work. Oh. Looks like it worked.
Oh, let's see here. So it shows that it had a fault, but it may have actually worked. It may have actually stopped that. It did. Or did it not?
Still work?
I think it's still alive. Let's try it again.
Oh.
Yeah,
I guess
it's
they're.
welded to it
I guess
now,
we use them for a good reason.
but it still tripped the circuit. That's impressive. I wasn't expecting that.
I zapped some magnesium, but the results weren't that impressive, relatively speaking. It melted too easily near the contact points and prevented burn through. So, I decided to try manually keeping contact.
Wow, look at how bright that is. It's like perfectly white on the camera. Do it with titanium! I love titanium!
That is crazy.
Let's try the same thing with ferrocerium.
Titanium! Whoa, okay. That's pretty cool. That's pretty cool. You know what? That's pretty cool.
Yeah, it's like that one explodes a bit softer than the magnesium did. That's cool. In fact, I bet ya. Where's my science machete? Oh, that's fun.
I think titanium should be even more impressive since it has such a high
Titanium!
melting point.
I love titanium. I don't know if you picked up. Yep. It's so bright. And look at how much longer it's lasting than the other one too, because it's so much better
That's
of a
how to light
material.
the entire yard on fire. Love it. All right, the titanium flamethrower.
Oh, it worked.
Yes, I got it.
So this is like the nighttime.
Oh, good, I got it. Huh, nice. Before light bulbs were a thing, there was something called a carbon arc lamp that was pretty much just an electric candle. Well, I want to try making one with my batteries.
I've connected a couple chonky graphite rods to some cable. I'm going to try initiating an arc by tapping them together.
That sound. That is not a good sound. You hear this sound, you run away.
That is incredibly bright. I smell like nitrogen oxides or something from that. Look how hot that is. I'm gonna apply a really heavy neutral density filter. That way you can hopefully see what that arc looks like.
Nope, it's still too bright. Oh, almost.
Now it's hard to tell, but that arc's actually getting huge. It's like hitting the ground there. That's not just from the splatter from the burning electrodes. The arc is gigantic.
Look at how hot
The
they are,
magnetic field
man.
keeps throwing it around.
It's so bright. I wish I knew what time of day it was. Seems like evening. Either way, it's still really bright.
I can feel the heat radiating back on me.
Even just the hot electrodes are bright, man.
I think it's time to revisit the huge bolt that I couldn't melt earlier.
Alright, I've got a fresh new 1-inch bolt in there.
If you want to see his failed attempt, you have to watch the original video, because I skipped past that one.
Hopefully this time will be the charm.
Here we go.
That's so many sparks.
Yes! Oh, it melted.
Oh, look at that. It finally burned through.
I thought it got away.
There's so much heat coming off of that right now. Yeah, I'm pretty sure the radiation coming off of that bolt lit that wood on fire. Wow.
The thermal radiation.
That thing got hot.
I clocked a peak of just a hair under 50,000 amps there. That's quite a bit more than the average lightning strike, and for a much longer duration too. Total circuit power there was on the order of 3 megawatts.
You should not be measuring anything in mega for a YouTube video, Drake.
I don't know. I think it's pretty cool.
Who gave you these batteries?
Any desk, yeah. It was their idea. It's insane. That's right.
You know what? I said bad about AnyDesk. I like AnyDesk now. AnyDesk, actually great. They just need to, work on their software, getting it installed easily, but...
This video is sponsored by AnyDesk.
Mm-hmm.
In fact, this entire video was their idea, which definitely makes them my coolest sponsor.
So, what is AnyDesk? AnyDesk gives you lightning-fast connection to all your devices.
For example, I don't even need to be near this terrifying battery bank when I want to blow something up with it.
I can walk into an Arby's 1,000 miles
Actually, I think I was lying on AnyDesk. It was not AnyDesk that was on my sister's computer. It was something else that had a similar name.
from my lab.
AnyDesk
and
is
remotely
great.
fire the batteries in a tiny fraction of a second. I love the future. AnyDesk isn't only useful for shorting 100 car batteries. You can remotely control and manage all your devices with
I
low
would never
latency
edit
and on low
remotely.
bandwidth. The other guys are notorious for being laggy at the worst possible times, but AnyDesk is always
plugged-in
lightning
computer?
fast.
If you're cursed by being the most tech-proficient member of your family or friend group, well,
Yeah.
AnyDesk can save you time and frustration there too.
You can remotely support loved ones from wherever you want to be. AnyDesk
I'm there
is
all the
free
time.
for personal use and offers business plans that are custom tailored to your IT and work from home needs.
Download AnyDesk now at anydesk.com/styro.
So yeah, a big thank you to AnyDesk for sponsoring this video.
Oh, I gotta say, it took a lot longer to make this video than I expected. Now, part of that was I probably spent too much time with the 12-volt experiments, but also is I really didn't know what to expect from 100 car batteries. So I mean, with most of my videos, I have a pretty good idea of what the end product is gonna look like. But with these, I really didn't know. I mean, I just had to throw things at the wall to see what stuck. And this led to a lot of failed experiments, but at least a few of them were interesting.
I tried microwaving the output of the batteries, hoping it would make a super hot plasma, but the most I could get was a pop. The voltage just isn't high enough for this kind of thing. I also tried saltwater electrolysis, which did.
If you want to see the failed experiments, you're gonna have to watch the original video, I guess, because,
Now, the hardest part about this project was actually coming up with a switch. So, I mean, you can't just buy a switch like this that can, disconnect these huge currents, at least for less than you'd pay for all these batteries. So, my original intention was to build a solid-state switch using, a huge array of MOSFETs. I realized that would probably have a really high chance of catastrophic failure. So, I nerd-sniped the members of my Discord server with the hopes that they would come up with a solution.
This was a unique challenge, but I got a lot of creative ideas ranging from MOSFETs to mechanical devices, and even a cursed mercury switch. The Tesla coil
Mercury
master Greg
switch.
Lay suggested something hydraulic, which gave me the idea to modify a log splitter. I bought a cheap log splitter and some monstrous copper plates, and then brought them to my friend Josh to weld them up. It was his idea to use the internal spring mechanism to switch it on, which significantly helped keep the switch resistance low when firing. As a side note, this is the same Josh in my early pyro experiment videos that predate my YouTube channel.
So,
He
yeah,
sounds no
thanks
different.
to Josh for building the switch. Thanks to all my Discord nerds for the engineering consult. And thanks to AnyDesk for both sponsoring this video and giving me the video idea in the first place.
Finally, I'd like to give an ode to the lead-acid battery. These things are tough as nails.
AnyDesk okayed
Invented way
this?
back in
They were like, yeah, this
1859,
is a great
making them
sponsorship
the
for
oldest
us.
rechargeable battery technology. They're also the most recycled consumer product in the US, making them the most sustainable battery technology. To
Very
top it off,
sustainable.
they're the preferred source of charge for electric eels, fulfilling a critical role in aquatic environments.
Of course.
Thanks for watching.
Okay. Okay. This is a great video. I wish I could do stuff like this, man. It seems so fun, man. Really great video. I'm glad he did the stuff with titanium. I love titanium. Just an aside, I love titanium. I don't know what it is, something about it, just great. Love it. I don't know if you noticed this, but like 3 or 4 times while I was watching this video, people came in, so there's gonna be cuts. And if you know where those cuts are, put them in the comment section if you found them. Give me the timestamp here. Just a little mini game. But anyway, yeah. If you like this video, follow his channel. Go check out his original video for the parts that I cut out. And like and subscribe to my channel. And if you have anything you want me to watch, go ahead and put it in the old comment section below. And I will look at it as long as it's not, you know, an hour long. Because an hour long is pretty long, I gotta say. But anyway, yeah. Have a good one.